Hello everyone! In this video we explore the B-2 Spirit, the most iconic and expensive bomber in the history of warfare. How was this invisible giant born? What were the challenges in its development? What are the avionics behind its superior stealth technology? What weapon systems and bombs does it use? What is the engine technology that can keep this monster in the air? All in the video, stay tuned! One of the greatest strengths on the battlefield is to be invisible to enemy radar. That's exactly what the B-2 was built for. Thanks to its superior stealth capability, it can sneak behind enemy lines without being detected by radar. Although it was produced in the 1980s, its active use today is proof that it is one of the indispensable characters of the United States Air Force. The story of the B-2 Spirit begins in the shadow of the Cold War. In the late 1970s, the U.S. Air Force was looking for a solution to circumvent the Soviet Union's advanced air defense systems. What they needed was an aircraft that could carry high-capacity bombs, be invisible to radar and other defenses, and bombard enemy defense lines and critical areas. Northrop Grumman proposed the flying wing design for this mission. The design looked like something out of a science fiction movie. But surprisingly, it did not have a conventional fuselage or vertical stabilizers. The flying wing design aimed to minimize the radar signature. This aerodynamic structure would be a great advantage not only against enemy radar, but also against thermal and acoustic signatures. However, the B-2's wingspan and design were similar to the YB-35 and YB-49. The YB-35 and YB-49 were Northrop's flying wing bombers, whose development was canceled in the early 1950s due to their small radar cross-sections. Northrop overcame these problems, and development of the B-2 Spirit began under the Advanced Technology Bomber, ATB project. This project led to the cancellation of the B-1A bomber, an aircraft capable of reaching speeds of around 2,400 kilometers per hour, Mach 2, and resources were diverted to the B-2 Spirit. The B-2 began production in secrecy in the early 1980s. The project was so secret that the existence of the aircraft was not officially recognized until 1988. Spirit made its first flight on July 17, 1989, opening the door to a new era in military aviation. It entered service in 1997 as the second aircraft designed with advanced stealth technology after the Lockheed F-117 Nighthawk attack aircraft. It had technology ahead of its time. The B-2's stealth was achieved with special radar-absorbing paints and smooth lines without corners. The engine nacelles were designed in an S-shape to scatter radar waves. Bombs hidden in internal compartments prevented detection by enemy sensors. What do you think is the most impressive feature of the B-2's design? Share your opinion in the comments. Initially, 132 B-2s were planned to be produced, but development difficulties delayed progress and drove up costs. Each aircraft cost an average of $2.13 billion, including development, engineering, testing, and production costs. For that amount of money, you could buy an average of 600 2025 Bugatti Chirons, or you could become the new owner of Real Madrid and Manchester City football clubs. Due to the high cost of the end of the Cold War, 21 B-2s were produced instead of the 132 targeted under the project. The United States Air Force currently has 19 B-2 bombers in service. One was lost in a crash in 2008, and another was lost in a crash in 2022. Even today, its technology is full of secrets and is constantly being modernized. With sensors that can see a car's license plate from 30,000 feet, it can hit dozens of targets in a single sortie. Do you think such a costly project could have been sustained even if the Cold War had never ended? Or are prestige projects in defense budgets a strategic mistake? Legendary for its stealth, the B-2 Spirit is the pinnacle of the United States' strategic bombing power. The B-2's weapon systems are managed by a smart system called Smart Bomb Rack Assembly, SBRA. This system can carry different types of bombs at the same time and release them precisely. The B-2 Spirit has two massive internal bomb bays, allowing it to carry a lethal payload capable of destroying 80 targets in a single sortie over enemy territory. In total, it can carry 40,000 pounds, 18 tons of bombs. That's almost 5 times what an F-16 can carry. The B-2 can drop 80 GBU-38 JDAM guided bombs with GPS attachments in a single sortie. The 5,000-pound GBU-28 bunker buster concrete-piercing bomb destroys bunkers up to 30 meters thick. With a range of 920 kilometers, the AGM-158 Joint Air-to-Surface Standoff Missile, JASSM, armor-piercing warhead enables the B-2 to destroy enemy air defenses without entering their range. The world's largest non-nuclear bomb, the GBU-57A B-MOP, weighing 30,000 pounds, reaches a depth of 60 meters and destroys underground bunkers. The B-61-12 thermonuclear bomb is designed to hit underground targets. With an adjustable explosive power of 0.3 to 50 kilotons, it is used for strategic nuclear deterrence. With 1.2 megatons of power, the B-83-1 could completely change the course of the war. The B-2 Spirit is actually a flying supercomputer, because this plane carries the most advanced avionics systems to operate alone in enemy territory. Here is the amazing technology of the eyes and brain of this ghost in the sky. The B-2 is equipped with modern communication systems such as Link 16 data link and high-frequency satellite communications. In 2008, the aircraft's 136 individual computers were replaced with an integrated processing unit that communicates over a fiber optic network. In addition, an open mission systems architecture called Spirit Realm 1, SR1, allows software updates to be performed more quickly and efficiently. The B-2's most critical system, AN/APQ-181 radar system. Thanks to its low probability of intercept, LPI feature, this radar is able to scan targets without being caught by enemy radars. Operating in 20 different modes, this system can detect any tank or air defense system on the ground while simultaneously tracking air targets. So how does it hide from enemy radar? Through timing and frequency hopping technology. Radar signals are so short and random that enemy systems mistake them for background noise. But what if the enemy develops the same technology? Could the war on stealth end up as a blind fight where no one can see each other? Your feedback is very valuable. With its 4 General Electric F-118 GE100 turbofan engines, the B-2 not only flies but also hides. The engine nozzle has an S-shaped design that disperses radar waves. This means that enemy radars cannot see the engine intake. This is one of the most critical parts of stealth technology. In addition, the exhaust gases are cooled by a special mixing system and spread over a wide area, reducing the thermal signature. This reduces the risk of being caught by enemy missiles with infrared seekers. The B-2's engines offer high fuel efficiency for long-range missions. With aerial refueling, the aircraft can reach a range of 6,835 miles, or more than 11,000 kilometers. In addition, the design of the engines contributes to extending maintenance intervals and reducing operational costs. Born in the shadow of the Cold War, the B-2 Spirit, one of the deadliest weapons of the 21st century, is still one of the greatest threats in the skies. Its story is a testament to humanity's connection with technology. But how far can stealth technology go? Perhaps the answer lies in the next generation of stealths currently being developed in a hangar. What do you think? Let's discuss your thoughts in the comments. If you like the video, please don't forget to press the like button, subscribe to my channel, and share it with your friends. See you in the next video.